Alright, this is the Unit 2B 0 period Part 2 video. If you have not yet watched the Part 1, you need to go back and do that. So find that video on the same channel where you found this one. Okay, we left off that video with you guys trying a couple of these inequality graphing ones. So I'm just going to show what I did for those. You guys check and see if you got the same thing. Alright, so for this one, you needed to solve for y initially. So that was negative 2x plus 5y is less than 25. Hopefully you added the 2x, and that made it 5y is less than 2x plus 25. Then divided by that 5, divided by that 5. So that made it y is less than 2/5 x plus 5. Now, with that, that meant a 5 was our y-intercept, and you were going up 2 over 5, so that was up 1, 2 over 1, 2, 3, 4, 5. And then going backwards, or I think we have root for 1, 1, 2, 1, 2, 3, 4, 5. Then same thing, but going backwards, so go down and to the left. So 1, 2, 1, 2, 3, 4, 5. Then 1, 2, 1, 2, 3, 4, 5. And then you can draw your line through. Now, thing, that is a less than sign, not an equal to, so that means it is dash. All right, so draw you a dashed line through. Now, it is less than, so shade below. Okay, and of course some example solutions could be 2, 0. Or 0, negative 6, anything down in there, right? Anything that is above would not be an example solution. Now, one thing to clarify a little bit, if something is on the dashed line, then it is not a solution. If something's on a solid line, then it is a solution. Okay. All right, let's go and do that other one. Check your work on it. Okay. So for this one, that was a x minus 5y is less than 40. And so hopefully you subtracted the x. That made it negative 5y is less than negative x plus 40. Then hopefully you divided by your negative 5. That made that y is, we divided by a negative greater than instead of less than. Negative divided by negative is positive, so 1/5 x, because there's an invisible 1, right? Then minus 8, because 40 divided by negative 5 minus 8. So, put that minus 8 here. Then you're going up 1 over 5, so up 1 over 1, 2, 3, 4, 5. Then up 1, 1, 2, 3, 4, 5. Then backwards this way, 1, 2, 3, 4, 5. Then 1, 2, 3, 4, 5. And then again, it's dashed because we're talking greater than, not greater than or equal to. And so hopefully you've shaded your area up in here. Okay. So an example of a not a solution would be 0, negative 10. Example of a solution could be anywhere up in here. I'm going to pick 5, 0. Okay. After this, we have some word problems where we have to make inequalities. Okay, so let's look at some of these word problems together. So this one says a group of friends wants to go to the amusement park. They have no more than $380 to spend. I'm going to underline that wording. No more than $380 to spend on parking and admission. Parking is $15.50, and tickets cost $20.75 per person, including tax. Which inequality can be used to determine P, the maximum number of people who can go to the amusement park? Okay, now we're going to assume all these people are going in one car, so they're just going to pay one parking fee, right? $15.50. Now, when you hear the word no more than, you might be tempted to think, oh, more than, that's a greater than. Well, yes, more than would be greater than, but no more than, we're talking about less, because that's flipping it because of that no, right? So no more than. And in this case, it'd be okay if they spent exactly 380. And so we're really talking about a less than or equal to 380, right? Okay, because it'd be okay if they spent exactly 380. Now, it said P was the number of people. Okay, so it was $20.75 per person. So let's make that 20.75 P plus their parking fee. So $15.50. So plus $15.50. And we said no more than 380, so that's less than or equal to $380. Okay? So that's what it's looking for, is for you to form that inequality. Okay? Let's do another one together. All right, a rental car company charges $62.12 per day. Underline that. $62.12 per day to rent a car and 5 cents for every mile driven. Faith wants to rent a car knowing that she plans to drive 500 miles, so we're going to assume she's actually going to drive exactly 500 miles, and she has at most $440 to spend. Okay, so we're talking about driving 500 miles, and she knows she can only spend $440. Now, so switch inequality can be used to determine D, the maximum number of days Faith can afford to rent while staying within her budget. Okay, so that said, D is the number of days. I'm going to underline that. So D for days. Okay, we know it's $62.12 per day. So let's start there. So $62.12 per day. So $62.12 D. And now, she plans to drive exactly 500 miles. She's very specific. That's interesting. But 500 miles times 5 cents per mile should tell us how much they are going to charge her for driving exactly that many miles. So, that would be 500 times 0.05. And I'm getting $25 for that. So that's plus $25 for that exact amount of miles. Now, if she has at most $440 to spend, it'd be okay if she spent exactly $440. It'd be okay if she spent less than $440, but not more than that, right? So that'll be less than or equal to $440. Okay. All right, one more of these, and I'm going to let y'all try some. So, Hamina needs to order some new supplies for the restaurant where she works. The restaurant needs at least 333 spoons. I'm going to say at least 333 spoons. There are currently 255 spoons. If each set on sale contains 6 spoons, so each set gets 6 spoons, which inequality can be used to determine S, the minimum number of sets of spoons Hamina should buy. Okay. So S is representing sets. Okay. So how many does the restaurant currently have? 255. There's 6 per set. So plus 6S. There's 6 per set. And they need at least 333. So that'd be okay if they had exactly 333 or more. So greater than or equal to 333. There we go. Okay. Now, with any of these inequalities, you could then solve it for the variable, but it is not necessary. But if you're trying to actually get the numbers that would work, then you would want to solve it. Okay. I have a few for you guys to try. There's this one and this one. Okay, so go ahead and try those two, and then unpause the video, and we will check them together. Okay? Alright, so hopefully this one went pretty well. A shipping container will be used to transport several 70-kilogram crates across the country by rail. The greatest weight that can be loaded into a container is 23,500 kilograms. So let's underline some stuff. So 23,500 kilograms is the greatest weight that can be loaded into it. And they're going to be doing several 70-kilogram crates. Other shipments weighing 13,000 kilograms have already been loaded. So 13,000 is already loaded. Which inequality can be used to determine X, the greatest number of 70 kilogram crates that can be loaded onto the shipping container? Okay, so the shipping container can only carry up to 23,500 kilograms. So for that means that we can do less than that, but we cannot do greater. We can do exactly that. So less than or equal to 23,500. Okay. So with the other shipments weighing 13,000, we already have that on the shipping container. So 13,000, then plus the 70 kilogram ones. Okay, and they labeled those X, the number of 70 kilogram crates. So plus 7X, and then we're done. Okay. All right, so then for the Omar and the bicycle one. So Omar has $660 to spend at a bicycle store for some new gear and biking outfits. He buys a whole new bicycle, okay, for $330.64. We all know that. He buys 2 bicycle reflectors for $15.34 each, and a pair of bike gloves for $34.47. He plans to spend some or all of the money he has left to buy the new biking outfits for $36.30 each. Okay, so let's figure out what he has already spent. So he's already bought this new bike, $330.64 plus $15.34 each times 2 of those reflectors. And he bought a pair of gloves for $34.47. So let's figure out what he's already spent. So if you haven't already, go ahead and add those up. I'm going to add those up now. I got $395.79. So that's what he's already spent. And then they're telling us which inequality can be used to determine X, the maximum number of outfits Omar can purchase while staying within his budget. Okay, so he's already spent $395.79. Then he has the new biking outfits for $36.30 each. The outfits were labeled as X, number of outfits. And then total he had $660, and it said he planned on spending, let's see, where did it say that? He plans to spend some or all of the money he has left, right? So we're accounting for up to all of it, and so that would be either less than or less than or equal to, right? Because he could spend all the money up to $660. All right, just a reminder again, guys, that what these are doing is these are corresponding to the delta math sections you should do. And so now that you've seen the day 1 and day 2 for these, there's this delta math section, and then this delta math section, or I should say these delta math sections that you can complete of the 2B recovery. Okay, stay tuned for part 3. We'll do the day 3 notes, which will cover that last delta math recovery.